Hello everyone, my name is Siddharth and I am an alumnus from IAT TVM. Today we will be solving a question that appeared in the NISER entrance test in the year 2015. This question considers a perfectly inelastic collision between two blocks of masses m1 and m2 respectively, and we are asked information about the ratios of the kinetic energy transferred to mass m2 to the kinetic energy that the initial block had. Now since this is a perfectly inelastic collision, we can conserve its momentum as initial momentum is simply mi into v1, that is the first block moving with initial speed, and since both blocks stick together and move after collision, then the final momentum will be m1 plus m2 into v2. From here we can see that we can write the final velocity of both the blocks as m1 into v1 upon m1 plus m2. Now the kinetic energy transferred to the second block will simply be the kinetic energy of the second block with this final velocity. So if we want to consider the ratio k upon k1, we can write it as the kinetic energy transferred to block m2 will be half into m2 into v2 square. We can substitute the value of v2 from the momentum conservation equation as m1 into v1 upon m1 plus m2, and we can square these terms to get the kinetic energy transferred, and the initial kinetic energy was simply half into m1 into v1 square. Now we can cancel m1 into v1 square and m1 into v1 square from here, half and half from here, and hence the ratio becomes m1 into m2 upon m1 plus m2 the whole square. Now obviously this equation is not constant for all values of m1 and m2, because if we keep the value of m1 constant and change the value of m2, it obviously is a variable quantity. Now if we want to find the maximum value of this quantity, we know in physics the maxima and minima of any quantity appears when there is symmetry between the two parameters. Over here, if we consider m1 equal to m2 equal to m, then the maximum value of this quantity is attained at m square upon 2m whole square, that is equal to 1 over 4. Now since the maximum value is attained for m1 equal to m2, point B is correct, and as we increase the value of m2 considering m1, then the value of this expression should decrease because m2 is in the denominator with a second power. So option C is also correct, and we have found out the maximum value is of course 1 over 4. So option D is also correct. B, C and D are all correct in this multi-valued question. Thank you for watching this video and subscribe to our channel for more such content.